talking about what problem we saw, it was really hard to pick an enterprise, and we were like, we have knowledge around across multiple verticals, so we tried to look into the holistic approach of every enterprise has an asset, every enterprise has a machine. So why are we limiting ourselves to look at a single site, single enterprise? Why not just open it all up to ingest all of the data from all the enterprises? And the problem we're trying to solve is all the assets that each machine has. It's a machine, it has data, it has KPIs. So how can we leverage agentic AI to detect those assets in real time and get insights out of it, onboard it into an ecosystem? Ecosystem could be your existing MES system, it could be your SCADA system, it could be whatever. But in the world of AI, how do you get there fast enough? We're not saying that this is going to help you completely eliminate the efforts of onboarding an asset, but what our efforts are to help you guys understand and get there fast enough. So there's a ROI to it. There's a time saved versus time spent. Money saved, money spent kind of aspect to it. So as you saw earlier on the screen, you had all these knowledge graphs popped up. So what we've tried to do is to understand the problem, you gotta, as a data scientist, you gotta look at the data first. And while we were trying to look at the data, we were like, okay, let's just let the floodgates open. We're going to deploy the agents. And the agents know a couple of things. This is a manufacturing environment. Here's the broker information. Here's the GitHub repo that talks about the enterprises. And that's it. I mean, ISO 95, agents kind of know that too. But that was it. So what I'm going to show you now on the screen is that I'm going to start the button and say ingest. And what's going to happen is real-time data is going to flow in, and I'll talk more once it starts flowing in. So I'm going to go to my screen, add data. Now we know at ProveIt, they've given us a broker. So I'm ingesting from a broker. Here is the pre-saved credentials of the broker. And if you would notice, we have subscribed to all three enterprises, enterprise A, B, and C. The wildcard hashtag means everything is allowed. And I'm gonna hit connect. So what's gonna happen now is the data is coming in real time. Agents are looking at the data that's coming in the live feed, and you will see a knowledge graph, a relationship between the assets from the topics get popped up. So you're seeing now on the screen real time how many assets are being detected. And if I switch over to the dashboard view, you can see there's a live feed of messages coming in. You can see the list of assets detected from the time I hit ingest up until now. So every time a MQTT message shows up on the broker from the ProveIt broker for an enterprise, it's creating this dynamic list of assets in real time. So I go back to the knowledge graph, you'll see it's popping up a lot, right? Every node has some kind of a meaning to it. It is that you can see lines popping around. There's data points shooting each other. All that says that I'm related to this guy, the parent-child thing, relationships, and mother, father, grandfather, whatever. The ISO 95 model is being mimicked here. Maybe you might not be seeing the color coding very well, but the bigger the bubble, the more relationship it has. So obviously enterprise is the biggest bubble because it has everything underneath it. So we were like, okay, I'm opening the floodgates, and in real time, agents are building this knowledge graph for me. What do I do? What insight I'm getting already from this? So look at the hierarchy on the left. It has auto-populated the hierarchy of the enterprise, and it kind of gave you like a high-level SCADA view of, okay, we have 3 sites, perfect, okay. Out of those 3 sites, I have, sorry, I went too fast. Okay, I have liquid processing, I have tank storage as a line. There's so many cells, I have tank 3, I have equipment. I'm just drilling down. Now, You see the two red boxes? This was something that worked out in our favor. So usually, agents hallucinate. We all know, we ask it something and it probably gives you a response, and sometimes it's accurate, sometimes it's not. So in this case, it started doing a little more thinking for us and was like, well, if this is a flow rate, it shouldn't be 0. Or if this is a performance value, it shouldn't be 0. We're not saying this is right or wrong. What we're trying to showcase here is that, look, we ingest the data right in front of you. It is in real time using agents to decipher all of this and detect the assets. And how do we onboard these assets now into our existing SCADA or MES or other ecosystems is what we're trying to prove it here. So I'm gonna tag in my brother here, Jacob, into the next part of the demo, so please.
I have been able to have the ability to 3 months hack on the future. So the premise here was I wanted to deliver something truly groundbreaking. So we're actually gonna have participation as well. What was your name? Ian? Ian is going to onboard an asset into the unified namespace. So everyone at this conference got given a unified namespace deliverable, but hardly anyone was talking about the work that goes into building a unified namespace. And many people know that's the hard work. That is the work that we're paid to do largely, and everything follows from building a unified namespace. So I am seeking to fully automate the building of a unified namespace from a single event. So Ian is going to onboard this machine. This machine is going to start publishing after to the public broker, and you'll be able to see your machine later on a dashboard and monitor its progress. You can keep me completely honest. This is real. There's no smoke and mirrors here at all. I'm gonna plug a PLC. This is running an actual PLC with ladder logic on it. It is a machine that is executing operation, and it's using PLC Next, Phoenix Context, open soft PLC. This is a real PLC I'm connecting. And I am not going to touch the keyboard from here on out. So we're gonna connect the machine. All right, so hopefully you can see the screen here, but I'm gonna walk you through everything happening from this point forward, our agents doing everything. So what it's doing right now is I have an MCP server on the PLC. An agent is using the MCP to explore the PLC ladder logic, tag names, metadata, comments, everything that could be considered semantic. So it's intuiting. You see it's detected that this machine, Ian has onboarded an industrial fluid mixer. He is installing one. These are the tags available. This part is fetching. It's using this context to hit Midjourney. Just a flavor thing. So it'll generate an image. So this is the fluid mixer, the industrial fluid mixer that's running on this machine. Some things you're about to see will be a little abstract. I'll try to explain them as linearly as possible. If you're curious, reach out afterwards, and I will do my best to explain how this all works to anyone that wants to know. This has explored the namespace, the real namespace. Every single message across this broker is being vector embedded right now to a knowledge graph. 12 million nodes, 68,000 topics. It is automatically modeling, so things are going to be moving pretty quickly from here on out. It's reading the rungs of the PLC and intuiting and inferring their function. So it understands that, a safety rung. It understands the I/O. It understands what it's connected to. And all of this is being provided back to the context. It's all with MCP. So this has got an MCP server running on it that an agent has access to. Okay, so this is how often it is publishing. This one's not that cool, but this next one is so cool. SESME. We are told to comply to the SESME standard. In just a second, the agent complies the machine to the SESME standard autonomously. The agent is hooking into GitHub, the SESME repository, and understands the spec and is applying that spec to this PLC, this industrial fluid mixer. This is where we're landing. You see the topics here. We onboarded. It's going to be on the UNS. We've done that first step. And I'm also, I also did everything else too, because of course you have to. So we're done with the UNS. Next, I will show you what follows. So a lot of you aren't here yet. You get here, then you get what I'm about to show you next. This is a different machine, so that machine is still onboarding, and in about 30 minutes, 15 minutes, you'll see it in the list. You can come back, you can see Ian's machine, I'll show you, that he onboarded. This is another machine that Nathan onboarded. There's an individual that came by the name of Nathan. So this view, 3JS is awesome, by the way. Use this library. Visuals are very powerful, and this one is no exception. Observability is a huge challenge in this space. So this is the knowledge graph I was talking about. Every single node, that's 13 million nodes. Each one represents semantic meaning. It's a little abstract. If you aren't familiar with vector embedding, watch some YouTube videos. It becomes intuitive pretty rapidly. But these lines that you see, these blue lines, are RAG retrieval. So they're semantically similar nodes on the broker to the conveyor belt. So those might be companion machines like other conveyor belts, or like a palletizer going out of a conveyor belt, or a scan tunnel, a Cognex scan tunnel on top of. I don't think we have any Cognex scan tunnels in the broker, but we very well could. Regardless, automated statistical ML models, pretty trivial. So once I've got this machine as code, I just tell the agent to deploy a multilinear regression model or time series model on that data. It's that easy. So statistical ML, multilinear regression models, this is all auto-generated, by the way, from that single connection event. So I'm going to show you fully generated MES. So we've got a product called Spark MES. Manufacturing execution system, for those who know that. I've integrated with that product with agents, and it generates dashboards through that product we have autonomously. this, I really want to talk about this. It's a wake-up call for me. I started as a controls engineer, did ladder for 3 years, R&D ladder. PLCs were where I got my start. Every single rung is composed by an agent. All right, so this is our SparkMes product. This is the autonomously generated OEE for that conveyor belt that I was just showing you. So Ian's machine will also generate a complete dashboard as well. I'm not going to go into the details of how I did that. Long story short is I developed my own MCP for ignition. Anyone who wants to talk about how to do that, well, for one, I open sourced everything. This whole stack is open source MIT. Please fork it. We have the obligatory chatbot. So, I will say this: chatbots are old news. Chatbots are easy to implement. They're also one of the most powerful things you can implement quickly. So, if I already have a unified namespace, put a chatbot on it. Give that to the guy that guy was talking about, the robot guy. Give it to him. He can solve problems. Like, look at this. It's giving me data. It's recommending things to do to improve my robot, performance, etc. So easy. You can do this in a day. You can do it with Codex, GPT, Gemini. It doesn't matter the model. Say, build a chatbot for my data source. Doesn't matter what the data source is either. Pi, SQL, MQTT in this case, whatever. Build a chatbot. This one's just kind of an experiment. It's going to be a publicly exposed ProveIt GPT. It works exactly like ChatGPT. It's going to store history for everyone at the conference who asks questions. Its RAG source is the entire broker. Ask anything. So it's saying injecting RAG sources. I'm trying to explain how this is working. So once again, if you want to know how to do this, contact us. Look at that open source repository. Ask anything. In the same way that you would GPT. Hopefully you've been keeping me honest. If you noticed, I didn't touch my keyboard a single time.
So thank you, Jacob.
Yeah.
That was very insightful. So trying to wrap it up for us, right, and give the audience like a summary of what we went through.
Yeah.
So coming back from the idea of, we saw the opportunity to detect all the assets that are available in all the enterprises. And we wanted to onboard them, but onboarding them doesn't really mean you just give you a list of those assets. Onboarding them means you're able to explore the insights that the assets are giving you. So you saw, if I may have you pull up the RAG, the matrix visual again on the thing. What I wanted to have everybody realize is that those nodes, when we started earlier, you saw me reset it, right? And I was ingesting it real time. You saw me reset it and I restarted it. It has become 659 nodes so far since we started this. So that many assets were identified with a proper message from the agent. Again, that part of our journey, beginning journey of our agents, was just giving us this insight. But this visual here that you see is actually, like you said, 12, 13 million nodes, and it actually crashed our pods.
Yeah.
It crashed our CPU.
People need to know this as well. I learned a ton. I deployed this on 16 vCores, 64 GB RAM. I thought I was good. I'm using the lightest weight embedding model I can find. It's an open source embedding model. I can't keep up with the broker. It's backlogging like crazy. And the vCores, they're all being consumed. So compute, the ramifications of compute are enormous. So we'll have to solve that in the future.
Yeah. So this system this system is not at all a fully productionalized system.
Yeah.
Our whole idea was that we're learning as you guys are learning, and we wanted to open source it for you guys. We wanted you guys to have, as much power as you can to leverage this, to take the industry where it's supposed to go with, as a community. We wanted to, so the way in a one-liner, the way we are auto onboarding is we detect an asset, we do a match kind of lookup, for all those Excel people out there.
Yeah.
You can call it similarity search, you can call it RAG search, but our agents are using that 13 million node as its memory to read the assets, similarities, and then he goes, yeah, okay, I have seen this machine before. Here are the topics. So if you scroll down,
Yes.
if you scroll down,
at the very bottom.
Yeah. These are the topics.
Topics that were returned with RAG. And so this speaks to HIDL. So a lot of people, 63% confidence. So people are like, how do we manage HIDL? You manage it around the confidence. The lower the confidence, the less you trust. So one of the common things is AI agents hallucinate. Of course they do. They're probability models. They'll always hallucinate. In fact, mathematically, you can't make them not hallucinate. We solved hallucination. There are all kinds of methods of planning around hallucination. It's not, we're beyond that. So if you want to understand that more, you could, reach out to me, but that's important to understand. Yeah.
Yep, so what we did was we identified the asset from a topic, did a similarity search, found a related model, created the ingestion model, and something like ignition, when some of you can relate to it, it's a UDT. It's a JSON key value pair. We generate that JSON key value pair autonomously, take that JSON key value pair, go into ignition, import that. And you saw that, and then we generate our Spark MES configuration autonomously, go upload that into Spark MES, import that, go to Sesame. Yeah, this is the back end of ignition that he's showing on the screen right now.
Yeah. So the agent, I assume, I didn't use Ignition's official MCP. We'll be doing that. We're experimenting at Flexware doing that. The MCP is building these UDTs. So the agent's building these UDTs. That's how I automated the view. We can meet customers wherever they're at in their journey. We deploy, Flexware has deployed UNS at around 10 to 20 of Fortune 100 companies and many, many, many other smaller companies. And we've done UNS deployments at massive scale. That is the first thing you need. Well, what comes first is connectivity, then there's UNS. Walker says it, connect, collect, analyze, visualize, or I don't know. He does it much better than me. He's right. Those are the steps. What I showed you is on the bleeding edge. In fact, it's so bleeding edge, we're still learning. If somebody's like, is what you showed the future? I don't know. I have no idea. It's where I've gotten to. So, but we do the rest too. We do the fundamentals. If you need the fundamentals to get there, then you can come to us as well. Yeah. Thanks, Jacob.
Yeah. So again, thanks to everybody for having us, giving us the opportunity to go ahead and showcase our ideas and just letting us play, right? So we went from detecting an asset, onboarding it into different ecosystems, creating a Sesame profile, pushing it up, to the Sesame GitHub repo. Everything was autonomously done. Now we did have, at certain points, we did have a checkpoint of, hey, if we saw that Ian was importing a machine and Ian saw that this machine is not actually behaving the way we want it to behave, he could have taken control of it and just say, hey, we don't use Celsius, we use Fahrenheit, we're in America, right? So things like that could be redone, and you could put a human in the loop and do all of it. So with that, I'm gonna follow the community and answer those questions. If you don't know already, what did we try to solve? Well, we saw the opportunity of solving asset onboarding as a challenge because it is a very laborious process. It is very cost heavy, and it is time consuming. But agents, and we're not saying it is 100% autonomous. We're saying that agents could help you get there
100%.
fast enough to save you some money and time. So that's our problem. So we ingested all 3 enterprises and tried to onboard them all autonomously. And again, this is all on open source, GitHub. Please come by and take our QR code. Go ahead and take our QR code. It has the code on it. Use your agents to point to it and play with it. How did we solve it? Well, by spending a lot of midnight oil. We spent about 200 plus hours, and that takes into another question: how much did it cost? 200 plus hours, $150 an hour, it cost $30,000. We're thankful to Flexware to let us do this, our little science experiment. But yeah, so the company invested $30,000 of our time to let us prove this and showcase that there is some value here. And how do we productize this as a community? Well,
Yeah.
maybe there's a product, maybe there's a solution, but we're exploring it as you are.
Yeah. Walk that journey with you.
And how long did it take us? We started talking about the concept
Months ago?
4 months ago. In October, there was a roadmap created, and then I showed the roadmap to Jacob. Jacob this is awesome, and let's go from here. And but then our day-to-days, we still have to be billable. So we got ourselves some time every week and started chipping away on it. And we had weekly syncs to look at where we are at, what we've done, what could be improved, and is this possible or not.
Yeah.
Showed it internally to a lot of people. Thanks again. This was Jacob and Nader from Flexware Innovation. See you next time.